Now, just because we use this law for non-right triangles doesn't mean it won't also work for right triangles. It will. Just some interesting things happen. Cliffhanger. So, I think we need to all be on the same page here. We're going to use the law of sines for non-right triangles. But what kind of non-right triangles? Well, when you're given ASA or AAS. You guys remember what that means? And this is not talking about two different triangles being congruent by ASA. This is talking about a triangle where you know an angle, let's say 60 degrees. The side right here is maybe 4, and this angle is 100. This is angle, side, angle. Or angle, angle, side. Yes, yes, yes. Girls? Okay. Angle, angle, side. Angle, angle, side. How do we remember this? Because some people who are crazy are like, well, Mr. Westphal, angle, angle, side. No. What's wrong?
I thought SSA exists.
I haven't done SSA yet. I'm talking about ASA and AAS. That's what I'm talking about right now. Do you all understand? How do we identify ASA? I'll get to your bad word in a minute.
The side has to be in the middle of the two angles.
Yes, for ASA, the S has to be between the A's. Yes? Awesome. Now, what if we have two side lengths and the non-included side, the bad word? Go ahead, Kelsey. What's your question?
I just don't think it exists.
It does exist.
Liar.
Liar.
Whoa. Rewind. What did I say didn't exist? The bad word for congruence. Silas. You can't prove two triangles are congruent by the bad word. SSS, SAS, ASA, AAS, and HL. Hey, people, those were used for triangle congruence. We're not talking about triangle congruence. We're talking about solving for missing parts in a triangle. In the bad word, it's a triangle. It happens. Like, for example, Kelsey's you're so excited right now. Angle. Side. Yes. You thought I was going to say that word. That is a classic angle side right there. Okay, you got to watch. For it. Watch. Now, did I prove any triangles are congruent by this? No. But can we solve this triangle? Yes. Are you ready for your first law of sines problem?
No.
I take that as a yes. What do we have here? The old bad word? The angle side or the angle side angle? Is the S between the A's? So it's angle side. Angle side. Use the law of sines. Use the law of sines. Now, why am I making a big deal out of that? Because tomorrow, we're going to have to use the law of cosines for other types of triangles. Law of cosines. There's no law of tangents. Huh?
Why is there no law of tangent?
I don't have time. I don't have time to talk about it right now.
Can we talk about it tomorrow?
Can I just give you a preview?
No. Do you love teaching?
No. Does it appear that I do? That I enjoy teaching?
So what though?
Who said no? Does it appear that I enjoy
What does it
teaching?
mean?
I'm pointing to you. I'm pointing to you.
I'm just kidding. I love teaching.
Why? Stop lying to us.
From eating.
Now, do you agree this is the law of signs, just with different letters used, not A, B, and C, but F, G, and H? Yes? Now, I told you we're only going to use 2 of the 3 fractions, correct? Yeah? Okay. So now it's time to decide. Which 2 pairs am I going to use? Well, you can only have one unknown in your equation, right? You can only have one unknown. So if we're going to solve this triangle, do you agree we're going to have to find the measure of angle G? We're going to have to find side G. And we're going to have to find side H. Yes, yes, yes. Angle G is really easy. Go ahead and do that one first. How do we find angle G? 39 plus 32. And then take it away from 180. What you got? 109? 109 degrees. Easy. This is not a right triangle. We're not using SOHCAHTOA. Okay, well, if I could only have one unknown, what are we going to solve for, or does it matter what we solve for next? What do you want to find next? Little g or little h? Sure. So here's h. If we're going to find h, by the way, I'm going to use the way I wrote it is fine. I told you if you want to find the unknown, typically we want it in the numerator. So if you know you're finding h, you could do h over sine of h equals g over sine of h. You could do it that way. Because I have it like this, I'll do it this way. All right. So we're going to do sine of h over h equals, well, let's fill in the numbers. Sine of 32 over h. H is my unknown. Everything else in this setup has to be known. So what other fraction do I want to use? The f's and sine of f and little f? Or sine of g and little g? F and little f, because I don't know little g. I can't use that pair. I would have 2 unknowns in the same problem. So we're going to use sine of 39 over 40. So we were using sine of angle f over little f. Do you agree? Are you all with me where this setup comes from? How do we solve this now? Don't type stuff in and get decimals. Don't put decimals in the problem until the very end. Cool. Cross multiply. Thank you. So do you agree? I get h times the sine of 39 equals 40 times the sine of 32. Last step, divide both sides by, hello? Sine of 39. So 40 times the sine of 32 divided by the sine of 39. Be careful with your parentheses. I always put parentheses around my denominator. 40 times the sine of 32 divided by parentheses sine of 39. Now, it'll probably work without. I'm just extra careful. I'm getting 33.68. Freeze. H is 33.68. Now, stay put. Look up here. Isn't that reasonable? That's less than 40 because it's across from a smaller angle. Last thing, if I want to find side G, I would do sine of 109 over G equals, use this one again, sine of 39 over 40. Are you with me? Your only homework for tonight is page 495, 13 to 15. Just 2 problems. Make sure you set them up correctly. Have a wonderful day.